In the following video, we're going to go through an example on how to use linear programming. So for this example, it says find the max value of f of xy equals 2x minus 3y for the polygonal region determined by the system of inequalities. And this system reads x is greater than or equal to 1, y is greater than or equal to 2, and x plus y is less than or equal to 6. And so let's get started on this. So I'm going to use blue for my first inequality, x greater than or equal to 1. Well, that is a vertical line that goes through 1 on the x-axis, and it's a solid one. And so I'm going to grab a solid vertical line, go through 1 of the x, and then I'm going to shade. And so the way I shade all the greater x values, which would be to the right of this line. And so remember, just like I said, when we're doing systems of inequalities, I would use a pencil to allow for erasing for this. And so then let's do y is greater than or equal to 2, and I'll use green for this one. So that means it's a horizontal line through 2 on the y-axis. So it's solid because it's greater than or equal to. And I want to shade towards all of my greater values, which would be above the line. And so when I shade above my line, I'm going to look for the crisscrossing pattern of my lines, and that represents so far where our feasible region may be located. So I see it's up in this upper right area, so I am going to erase the other lines that I drew, and so that way I can focus on that one area. And so now I have to graph the last one, and we'll use purple for this. So to graph this one, I'm going to put it in slope-intercept form. And so I'm going to subtract x from both sides. And that gives me y is less than or equal to negative x plus 6. And so I have a y-intercept of positive 6. So up at 6 on the y-axis. I have a slope of negative 1, so down 1, right 1. Down 1, right 1. And you're going to want to go across the entire grid because the whole point is to find our vertices of the polygonal region, our intersections of these inequality graphs. And then this is also a solid line because it's or equal to. And so I'm going to sketch my solid line. But this says y is less than. So I want to go towards my lesser y values, which would be below this line. And so when I graph below the line, I want to find the crisscrossing pattern of all three graphs. And it looks like it's this triangular region right here. And so I'm going to erase the other parts of my solution region. And I'm going to focus primarily on that triangular region in here. And so let's highlight that region for us so we can see it better. And so this is the region where my solutions are. So now what we need is we need to find the vertices of this region. And so if I look at this first intersection, that occurs at the coordinate 1, 5. If I come down, I see there's another intersection, and that's at the coordinate 1, 2. Now if I look at this third intersection for the triangle, that's at the coordinate 4, 2. And so what I do is I use these vertices and I plug them in. If we look at our function, it says the function of xy. I mean, this is a coordinate, x comma y inside parentheses. So what I do is I plug in my x and y values of the coordinates into the function to determine the value. So I have f of xy. So let's first do our f of, we'll do first 1, 5. So we have f, the function at the coordinate 1, 5, means twice your x value of the coordinate, which is 1, minus 3 times the y value of the coordinate, which is 5. So 1 is my x, 5 is my y, and that's what I plugged in. And so 2 times 1 is 2. You have 2 minus 15, which gives you negative 13. And then I'm going to do it again. I'm going to use the coordinate 4, 2. So the function value at the coordinate 4, 2 is twice your x, which is 4, minus 3 times your y, which is 2. Twice 4 is 8. 3 times 2 is 6. So 8 minus 6 is 2. Let me get some room to do my last coordinate, which is 1, 2. And so I have the function value at the coordinate 1, 2. Twice your x, which is 1, minus 3 times your y, which is 2. So you get 2 minus 6, which is negative 4. And so these are the values of the function based off of our vertices, our coordinates. And so I'm asked in this problem, determine the maximum value of that function. And so if I take a look, my values are negative 13, 2, and negative 4. So which one is the largest one? Which one has the largest value? And that would be 2. And so my largest value, we'll write it like this. There is a max value of 2, and that occurs at the vertex was 4, 2. And so that is the solution, the answer to this problem. Our maximum value is 2, and that occurred at the vertex of 4, 2 on our graph. So it relates the idea of graphing systems of inequalities. You find the vertices. That gives you your x and y values for your function, and you plug those vertices in and determine what the problem is asking. This problem is asking just for the max. And so we state what the max value is and at what coordinate created that max value.